All right. Welcome everyone to the introduction to FHIR, or rather the second introduction to FHIR. This is a repeat session from this morning. So you probably missed this morning session for some reason. I know there's a lot going on at the same time at DevDays and it's so hard to keep up. So welcome to this session. My name is Simone Heckmann. I'm a CTO of FHIR. We are a small company in Germany. We are doing FHIR trainings mostly and consultancy, supporting companies that are developing FHIR solutions, giving them advice, and trying to get the FHIR community in Germany together. So the first thing that I would like to introduce to you is HL7 as an organization, because the term HL7 causes a lot of confusion these days, because HL7 is also a standard, mostly HL7 version 2, but it's often just people just often say the HL7 standard, and what they actually mean is the HL7 version 2 standard, where the organization HL7 is the organization behind this standard that developed HL7 version 2. But when people use the term the HL7 standard and mean HL7 version 2, they often say that this is like the old standard. So HL7 is often associated with being a little bit obsolete, being old school, being not modern, whereas FHIR is, you know, the new stuff, the new standard that people are using. So the terms HL7 and FHIR are often seen as opposite things. But in fact, HL7 is the organization that is behind both the version 2 standard and the FHIR standard. The idea of HL7 is to be a worldwide organization of volunteers that work together to develop standards for healthcare. And it's actually very easy to join in the process of developing these standards. If you go to the HL7 homepage, you can access the listserv. That's basically just email lists, and you can subscribe to the lists of these working groups and be notified on when they have their phone conferences, when they are meeting, what topic they are discussing, and it's quite easy to engage with these working groups. So the mission statement of HL7 is to create global standards for healthcare interoperability and enabling their adoption and implementation. HL7 is more than 30 years old, the organization. It dates back to the mid-80s of the last century. And as you can see, HL7 version 2 standard is one of the first products that have been developed by these organizations. And HL7 version 2 has been very, very successful in the past decades. It is estimated that as of today, around more than 90% of the communication within hospitals is based on HL7 version 2. And you can see from the sub-versions that HL7 is still under development. Currently we are on version 2.9. There will be more versions coming up. But the technological basis is still the same. It's still the same as it was invented back in the 80s. Of course, HL7 has continued to develop standards since then, and they have already in the late 90s started to develop what was later released as HL7 version 3 as a more modern approach to healthcare interoperability. And now FHIR is actually the youngest child of that product family, dating back to the year 2011. So in case any one of you has never seen an HL7 version 2 message, this is basically what it looks like. That's the state-of-the-art communication in hospitals, and it basically consists of a message-based communication where we have these different message segments. MSH, that's a message header, it has metadata. You have an event segment, PID, that's patient identifying information, PV1, that's the patient visit data, meaning encounter information. And then we have these pipe-separated bits of information that are encoded here. So I think it's pretty obvious that this is not up to date. This is not the way we would do communication today. HL7 version 3 was a new approach to the whole problem. And the idea was to have everything based on a reference information model. To, in a way, have this one-size-fits-all solution to healthcare, to have an abstract model from which you could derive anything, any object, any real-world object that you need. But the problem is that with the healthcare domain, it's confusing, it's fuzzy, it's diverse. We have different domains in healthcare. Every country has different structures in healthcare. So finding this one abstract model that fits all of it has been quite problematic. And what you can see on the slide is actually just a very small excerpt of this whole reference information model that is behind version 3. And I think a common criticism with version 3 is that it's quite difficult for developers to derive a solution to their real-world problems from this abstract model and to actually apply this to what they are actually trying to solve. So the status quo that we still have in hospitals today, is very much influenced by the way that V2 messaging works. We have primary systems that are basically masters of all this data, and the interoperability is event-based and message-driven. So whenever in the primary system an event occurs, like a patient is being admitted, patient gets transferred, patient gets discharged, lab report arrives, this triggers a message, and this message is distributed to all the systems to whom it may concern, basically. So whenever you want to introduce a new end-user application, you first have to set up your backend that is always on, always available, and can pick up these messages whenever they arrive. And there's no way of anticipating when these messages arrive. And also there is no way of getting the information from the primary system unless you have already captured it in your backend by basically catching one of these messages that has the important bit of information that you need. So that makes it quite difficult to add new end-user applications because you basically always have to add one of these ecosystems. You cannot just plug in a new end-user application because the communication between these apps and the backends is mostly proprietary because neither version 2 nor version 3 standards are really suitable for this kind of communication. So meanwhile, there's been a paradigm shift happening in the world outside. We're moving away from desktop devices. We're going to mobile devices, thin clients, zero clients. Our devices are getting lighter and lighter, and consequently, we are also moving away from software. We're moving towards apps, having highly specialized fragments of software that can be combined in a very flexible way, and so every user has the opportunity to create their own dashboard by putting together or selecting the apps that support their requirements the best. Also, we are moving away from the organizational records towards the patient-centric, longitudinal, lifelong health records, which also requires a whole new set of solutions. A lot is happening with cloud-based solutions nowadays that also requires a different set of technology from what we currently have. We are moving away from having these monolithic central systems that have all the information and never give it up. So it's basically the systems that we have these days are mostly one-way systems. You can get the information in, but you can't get it back out if you need it again. So what we basically want to move to is having like an open API-based approach to interoperability. And of course, we hear a lot talking about big data analytics, machine learning, AI, and all of these paradigms need structured data, need data that you can query, need open APIs in order to work. So these three guys, back in 2011, kind of struggled with the fact that none of the existing standards, neither version 2 nor version 3, are actually really a good fit to solve all of these problems that are arriving in the healthcare sector. So they basically started a new approach to look at it. And their idea basically was to have to create an open API for healthcare that would allow the data in these primary systems to be queried by the end user applications whenever they need it, wherever they need it. And that also allows not only to have the workplace apps, have web-based workplace apps that can access the data, but you can also have third-party apps that can leverage the information in the primary systems, and you can also add cloud-based solutions to cross the borders of your organization, to reach out to the general practitioners or even patient in their home environment where they maybe collect data with wearables, with sensors, etc. So the new beginning was basically based around the question, how would we solve this problem if we could start over again, if we could start from scratch? What would we do with all the knowledge and all the technology and all the experience from other domains that we have today to approach this problem? And the idea was basically to copy from solutions that are quite successful with the open API approach. And for example, a successful open API is what you find with Twitter, for example. If I ask a developer to integrate my software or my app with Twitter, they will say, yeah, no problem. Give me 2 hours and I'll be done. Because what do they do? They type Twitter API into Google, click the first result, find a specification of the API, they find code samples, they find libraries, they find a community that can help them if they have run into any questions, weird error codes getting returned, they will already find a solution. So it's really no big effort to integrate with such an open API. And so they were basically looking at what's the success factor of such APIs and try to replicate that for the healthcare sector. So that's actually how FHIR started off back in 2011. And from the first draft of the specification, they already, quite early on, they invited developers to come in and build solution based on this very early draft of a FHIR specification. And they got feedback from developers. The developers had ideas, they had suggestions on how to improve stuff, on where the specification should move. And basically the whole development process of FHIR is always a feedback loop from specifying new parts of FHIR, then giving it out to implementers and get their feedback and use that to improve the specification. We have always had really early releases that were called DSTU. You might stumble over this acronym a few times when you look at FHIR. These were called Draft Standard for Trial Use. These were early releases that developers could use to build stable applications on while the standard was still developing. And now in December of 2018, we got the current release, which is R4, and that's the first normative edition of FHIR. Normative meaning that the basic technology of the standard is now stable. There's going to be no backward incompatible changes on these parts. However, it's not the whole specification that's normative. It's a basic technology and a couple of resources, a couple of our most important data objects that we need. We will take a closer look at that later on. And of course, in consequence, that means that there will be future releases. We will have an R5 release, an R6 release, probably in like a cycle of probably 2 years from now. No, sorry, 1 year from now. We're already 1 year past R4, so it's going to be 1 year from now. All right. So the FHIR acronym basically means fast healthcare interoperability resources. And you see the focus is on having something that allows you to fast to have a fast integration, to have fast development cycles for integration solutions. And the means to achieve this fast and easy implementability is most importantly to focus on the implementers. FHIR is really targeting, trying to accommodate the needs and requirements of the implementers. And that also means that from the start, it was decided that FHIR would only specify the 80% solutions. Because in healthcare, you know, the rest, the other 20% make up a lot of the complexity. If you try to also specify something to fit for every country, for every healthcare domain, things get crazy complicated pretty fast. So by focusing on the 80% solution, that was actually taking a lot of complexity out of the FHIR specification. Also, we are focusing on using web-based solutions, reusing as much technology as possible that is commonplace and that all developers know, like RESTful approach, HTTP protocol, JSON representation. These are things that are common for all developers. And so we are trying to reuse as much of that as possible. We are also trying to make the information as human readable as we can. That means on one side that we have human readable representation in all of our machine readable structures. So as a fallback, we can always show the human readable part to the end user. And we also try to make even the machine readable parts as human readable as possible. So if you as a developer have to debug a system and look at one of these XML or JSON resources, you can actually read them. They are human readable. And of course, the most important part is that we are really, really trying hard to support the community, because the community is the biggest success factor of FHIR. It's the biggest asset that we have as a standards community, that we really have this huge group of really bright people with crazy, insane ideas that you can see at DevDays for 3 days. You can see all these fantastic things happening all over the world, and keeping all of these people together and helping each other out and exchanging ideas. And that is really one of the biggest values that FHIR has to offer. All right, so FHIR is basically a framework. I like to think of FHIR like one of these Lego boxes. It's basically giving you the basic bricks that you can use to build pretty much whatever you want. Your imagination is basically the limit to what you can do with FHIR. And when you look at the specification, it pretty much looks like one of these Lego boxes. You can see the different parts, assorted parts that you can use. You have parts that you can use to implement privacy and security. You have parts for conformance and terminology. And then we have our basic blocks. In FHIR, we call them resources. For administrative tasks, we have building blocks for clinical stuff, for diagnostics, medications, workflow, and so on. Now here's a long list of the building blocks, the most commonly used building blocks that we have in FHIR. And you can see the one with the green N box at the end. These are the ones that are in the current version are normative. The other ones instead have what we call a maturity level. It's basically a number between 0 and 5 that indicates how mature a resource is. 0 meaning it's really just a first draft, a pretty rough idea that hasn't been around for a long time. And then it's moving up in maturity by getting tested, by being used, by feedback being given from implementers. These are all things that move these resources up on the maturity ladder until eventually, if they've been extensively tested, if they've gotten a lot of feedback, a lot of attention from implementers, that's when they finally can reach normative status. If you want to use a resource with a low maturity level, don't be afraid to do that. You can do it. You just have to keep in mind that in the next FHIR release, that resource might actually look very different from the way it does right now. So best advice that I can give you is to keep in touch with the HL7 working group that is responsible for that resource. Not only will that give you a heads up when they are doing changes, that also gives you the opportunity to vote against these changes and make an argument on why you don't want this change to happen, or even put in your own change requests. If you have an issue with that resource and have a suggestion on how to improve it, a low maturity level will make it very easy to get these change requests make them a part of the next release in the specification. So let's take a closer look at one of these resources. Let's take a look at the patient. The patient resource, or basically any resource in FHIR, looks like this. We have this tree view that you can look at, and that's actually the most human-friendly representation that we have. You can see the different elements. They are also linked with, if you get a more extensive description of the elements. We have the data type columns. Again, you can click the links and follow, and then it will take you to the page where the data types are specified. And if it applies, you also have direct links to value sets. If you have a terminology binding and there's a defined list of values that are allowed for a specific element, you can find them behind the link to the value set that you have right there. So if you look at a patient instance, it could look, for example, something like this. This is the instance of a patient. And you can see in the blue box at top, it's what we call the narrative. That's a human representation of the structured content that you have at the bottom. And human readable in this case means just using XHTML markup. So in this case, we just have a little HTML table that has all the information in a human readable form. The yellow box has what we call extensions. So if your problem doesn't fit in the 80% solution approach that FHIR is following, you may have to use extensions. And these extensions may be used for stuff that is either domain specific or it's locality specific. For example, here we have an extension that's called US race. That's something that's specific to the US realm, where the race of a patient needs to be captured. But since this is only something that is only done in the US, it didn't make the 80% rule. It's not part of the core specification. And so that's why there are specific extensions for the US realm, as well as we have extensions for German profiles. So there's always a number of extensions that are specific to your domain. Now, in the green box at the bottom, we have the core elements, the one that you saw on the page before. And these are like, the most common things, whatever fits in the 80% rule, like name, address, birth date, the common things that you want to know about a patient. So we can see that's basically the practical application of the 80% rule. Now, let's take a look at the exchange paradigms. Often people see FHIR as something that is purely applicable to mobile application development. But that's actually not the case. Of course, people who develop mobile applications will drift towards FHIR because FHIR is giving you this beautiful RESTful approach, which is basically what you want for a web-based application. But it's only a possibility. Nobody says that you have to use a RESTful paradigm to exchange data. You can also do messaging the way we are doing it now with HL7 version 2, like packing up the information, having event-triggered exchange. You can do that with FHIR as well. You can also implement operations, something like a remote function call. If your server offers a specific service and you're exposing it through a RESTful API, you can do that. And we also have what we call services. That's basically the big box for everything else. So what that means is whatever means of exchange you want to use, you can do it. And your implementation will still be FHIR compliant as long as your content is compliant to the FHIR specification. And that's basically because there are a lot of specific protocols that are, if you have national infrastructures, sometimes you just don't have a choice of your exchange protocol. You have to use whatever is there in your country. So that's definitely allowed within the realm of FHIR. And then we have the storage part. That's actually quite interesting because a lot of implementers were really smart, and when they started to build new applications from scratch and they wanted to exchange using FHIR, they sometimes said, oh, why do we need to map the information from our data model, from our database model to FHIR and back? That's too much work. We're just going to store everything natively in our database. So they used non-SQL approaches, stored the FHIR data natively in the database as JSON resources or as XML resources. There are a lot of modern database systems that support that. And they were so successful with that approach that today it's actually really commonplace to use FHIR as a storage model as well. Now let's take a closer look at the RESTful paradigm. If there's someone in here who has never heard of RESTful approach, don't worry, we all know how it works. Because whenever you open a browser, you are using a RESTful approach to getting a website, for example. And what this basically means is that you're typing in the URI of the resource that you want to look at. In this case, we want to see the page index HTML from the hl7.org server. So we're putting in the URI, the server returns the page, and the browser displays it for us. And that's the exact same approach that we are using to access patient data in FHIR through the RESTful API. So in FHIR, to look at patient data on a server, you'd have to input the patient's URI. Additionally, you'd have to say what representation you want, because FHIR gives you the option to get either XML or JSON representation, and most servers actually support both. So you as a client have to indicate which representation you prefer. And then the server will return the patient resource with the information, with the elements that we have seen earlier in the specification. Now, what often happens when you're browsing the internet is that you do not know the URI of the resource you want to look at. So what do you do if you don't know the URI? You're using Google or any search engine. And what happens when you type in a search term into a search engine is that your search parameter gets encoded into the URI, and the URI is again sent to the server, and the server responds with a list of matching pages to your query. And that's the same thing that is happening with the FHIR Search API. If you don't know the URI of the patient you want to retrieve, you Google for it, which means you are encoding your search criteria into your URI, send your query to the FHIR server, and the FHIR server will return a list of patient data or a list of patients that match your search criteria. Now, of course, we do not want our end users to encode queries into URIs and retrieve XML represented data. That is, of course, stuff that we want to happen in the back end, and the front end is a beautiful URI, a beautiful user interface that maybe already exists and has to be upgraded to use FHIR, or something that is currently under development. So in any case, you want to use FHIR in the context of your programming language, of your programming framework that you're already using. And for that, we do have a lot of options in the FHIR community. If you're a Java developer, you will find the Happy libraries that you can use. If you're a .NET developer, you will find the .NET reference implementation that you can use. If you're an iOS developer, you will find a Smart library. And there's basically daily we get new additions to libraries. I think I've just heard that a new Python library is going to be shown around DevDays. So you will actually find a lot of things that you can reuse. Nobody has to start from scratch implementing FHIR. Now, whenever there's a new standard coming around, there's always the expectation or the hope that the standard once and for all will solve all our interoperability problems. And what people are always hoping for is to have this plug and play solution, like to have two FHIR-based systems and you plug them together and they're instantly interoperable. And I often get the question whether this is going to work with FHIR. And my response is, well, not exactly. It's a yes or no kind of thing. It's not a simple question to answer, but I will explain to you why. Out of the box, FHIR is not an interoperability solution because the expectation to have two developers, if you give them the FHIR specification and tell them, okay, develop a FHIR API, go. And expect them to end up with two fully interoperable solutions is the same as giving Lego boxes to kids, to different kids, ask them to build a house and expect to get identical houses. That's not going to happen unless you give them a plan on how to build a house. And the same is true for FHIR. Just giving an implementer the FHIR specification and say build something is not going to give you an interoperable solution. Maybe on a very, very basic level, but not what you are expecting. Unless you give them also a construction plan. And that's basically what FHIR is offering you. It's not only the box of bricks, but it's also an extensive framework on how to build these implementation guides. And the implementation guides in FHIR are really first-class citizens. They are not just documents like PDFs that you can give to your developers and say, hey, read this and you will know what to do. These are actually machine-readable specifications that you can use to validate your resources, to check whether you've built them correctly. You can use them to dynamically generate code, dynamically generate UIs. They will give you all the information that you need to implement not only syntactical interoperability, but also semantic interoperability, because they also contain the details on what terminology to use. And these implementation guides and all the parts that are in these documentation guides are also FHIR resources. So they can be retrieved and exchanged through a RESTful API, same as every other FHIR resource. So basically the interoperability of FHIR is not coming from the FHIR specification itself, but from the implementation guides. So I really encourage you, if you are new to FHIR and you're only starting to dive into the specification, is to get started by finding an implementation guide that is relevant to you. Because the implementation guide will also guide you through the FHIR specification and highlight the parts that are relevant to your problem. Because just reading the FHIR specification, it's quite easy to get lost. There's so much stuff there. And, you know, everything is linked. And if you follow 3 levels deep into these pages, you're quite easy getting lost in all this extensive amount of detail that there is. So I really encourage you to go to one of these pages, for example, the registry at FHIR.org, and just browse through the list of implementations guide that you find, and let the implementation guide guide you through the FHIR specification. Another way to find implementation guides is simplifier.net. That's basically where you find a lot higher number of implementation guides, but also a lot of sandboxing is happening. So people are, trying out parts of the specification. And there's also a lot of very interesting implementation guides out there, a lot of national profiles, for examples. But it's a little bit hard to find the needle in the haystack. So probably the best advice that I can give you on how to navigate the whole FHIR experience is to become a part of the community. And the easiest way to do that, aside from joining DevDays, obviously, is to join the FHIR chat. You will find it at chat.fhir.org. It's free for all. It's OAuth enabled, so you can log in with existing Google accounts, existing GitHub accounts. And in this chat, you will pretty much find the same people that you can talk to here at DevDays, but you can keep in contact with them even between two DevDays events. And this is probably the best way to get relevant information quickly without, spending hours and hours browsing the web and looking for a specific piece of information. It's always a lot easier to just ask in the community, because sometimes it is admittedly hard to find a solution to a problem, to find the one specific detail in a specification that you are looking for, or to find that one implementation guide that might be relevant to solve your problem. So please don't be shy and just ask on this chat if there's anything that you are looking for, anything that you are missing in the specification, anything you don't understand from reading the spec, please just ask in the community. Or ask me right now. We have 5 minutes left, so I'm happy to take any questions that you may have. Yes, FHIR messaging, well, with a REST approach, what you're usually doing is your communication is based on one single resource. You can update a resource, get a resource, delete a resource. Where messaging is the same as you saw with the V2 messages. Well, it was a package of information. It had information about the patient, information about the encounter, information about insurance of the patient, for example. So sorry. If you are exchanging information about an event like admitting a new patient, your message would contain information about the patient, about the newly generated encounter, maybe some context information. You would create a package, or as we call it in FHIR, a bundle, that also has meta information about the message and what the system expects in response and stuff like that. And then it's basically agnostic of protocol. What you do with your message bundle is up to you. You can use a RESTful approach and post the bundle to another server for processing, but you could also write it in a file or FTP it to a different server, or, I don't know, print it, scan it. Whatever you like. You're not tied to one specific protocol. But the messaging approach basically means that you have a trigger event, and then you are sending out a bunch of information about the event, and you have no expectation of what business logic is going to happen at the recipient's end. Whereas with REST, you are being very specific of what you expect on the other end to happen by saying, delete this, update this, create this. You're welcome. Any more questions? Yeah. A very basic one, yeah. What is this about relating? Okay. Yeah. All right. The question is, how does IHE relate to all of this? That's a very interesting question. I mean, the scope of what IHE basically does is it's another organization, but not an organization that is defining standards. It's an organization that is modeling use cases. So they pick a specific use case. A very famous one is the cross-enterprise document exchange or the radiology workflow. And they define this use case and they figure out what are the interactions that are needed to cater to this specific use case. And then they pick the standards that they think are the best fit to solve this specific problem. And what they are doing basically in using the language of FHIR is IHE are writing implementation guides. That is what they are doing. So, and that's actually happening with FHIR as well. If you go to this page, you will find that a lot of these implementation guides are from IHE authority. So we have implementation guides here that are authored by HL7 or HL7 affiliates, but there's also a large number of IHE authored implementation guides. So IHE has already, I think, about 30 different implementation guides that using FHIR as a base technology out there. Most prominently MHD, Mobile Health Document, which is also cross-enterprise document exchange, but based on FHIR, and a lot more very interesting implementation guides. And you will find them on this page, actually. Okay, final questions? Yeah. Yeah.
Hospitals are based on this. Is this what Europe or worldwide 80% are based on V2?
Yes, I think there's been a study out there judging the number of how high the percentage of V2 is, and I think it was in terms of messages sent. That made 80 or 90%. It's not a volume, because we also have DICOM messaging in hospitals, which is bigger in volume because the files are huge in DICOM, whereas HL7 messages are really small. But I think the study was looking at the numbers of messages or number of trigger events that they came up with 90%. I don't know if it was worldwide or specific to Europe. I'd have to look that up. So for a resource to mature, to crawl up on the maturity ladder, there's basically a list of checkboxes that need to be filled. There's a quality control process, like is the documentation complete? Are there enough examples? Are the terminology bindings okay? So that's something that the working group has to do, but there's also requirements that there has to be feedback from the community, from implementers. There has to be productive use of a specific resource in more than one country by more than 3 different vendors. So this is basically the bar that a resource has to cross to become normative. You know, just one vendor saying thumbs up, yeah, that's okay, that's not enough. And there has to be feedback from different communities. Yeah, actually, if you click on the numbers in the specification, the numbers are linked. If you click on any of these numbers, you will be redirected to a page that gives you exactly what the criteria for the maturity levels are. Okay, thank you. That's it. We're out of time, but feel free to ask me any more questions during the break. Thank you.